When you have one of these problems with the nth root and to the power, sometimes you can't actually take the nth root of the number inside, and so you're going to have to use a calculator. Now to do this on your calculator, remember I can write this as 5 to the 3/4 power. So on your calculator you're going to need a fraction to be able to make this. So first off, on a calculator your exponent buttons might be x to the y or y to the x, or otherwise a lot of times it's this tent looking thing we call a caret. And so what you do is you hit the 5 on the calculator, then you hit your exponent button, and then you need parentheses, and you just put 3 divided by 4, end the parenthesis, and then equals. Now if you don't use parentheses, then what's going to happen is it's going to look like this, and what it'll do is it'll find 5 to the 3rd power, and then it'll take that and divide it by 4. And you don't want that. You want it to have the 4 as part of the exponent. So on this one down here, this is 3 to the 3/4. So then on the calculator, it's going to be 3 exponent button 3/4. All right. Now one of the things we're focusing on in this video is solving using nth roots. So here, as always, we want to get whatever's being raised to the exponent by itself. So I'm going to get rid of the 2 first. So I have x to the 4th equals 81. And then I need to take the 4th root. So I'm going to take the 4th root of both sides. By the way, you could also write that, it was originally like this, you could also write that as to the 1/4 power. So you're raising both sides to the 1/4 power. It's the same thing, just written in a different way. And then now x equals, now 3 to the 4th is 81. But now I worry about, do I just leave it as 3 or should I have a plus or minus? Remember what we talked about previously is that when you have an even number there, you need that plus or minus, because an even number of negatives cancel out completely. And so I could have a positive 3 4 times and get 81, and I could have a negative 3 4 times and get 81. So I actually have my 2 answers here. Again, we are trying to get so that whatever is being raised to the exponent is by itself, and then we're getting rid of the exponent. So right here, all of this is being raised to the 3rd. There's nothing else around here. So I can go ahead and raise it to the exponent. So I'm going to raise it to the 1/3 and then raise this to the 1/3. So then the 3 and the 1/3 cancel out. So we get x minus 2 equals, now I don't know the cubed root of 10, neither do you. So we'll just write the cubed root of 10. And then we have to add 2 to both sides. So we have x equals 2 plus the cubed root of 10. Now, you could find this out of decimal, or you could just keep it as is. One of the reasons we don't find it as a decimal, we just keep it as is because the cubed root of 10 is going to be some decimal that goes on forever and ever. So if you write it as a decimal, that means you have to cut it off eventually, because you can't write it forever. And then it's not really the true answer. So a lot of times we just leave it as is in the root form. Okay, again, I'm trying to get what's being raised to the exponent by itself, so I need to get rid of the 5. So I divide both sides by 5. So y to the 4th equals 16. And then I take the 4th root of both sides. So the 4th root and the 4 cancel, so it would be y to the, and then the 4th root of 16 is 2. But again, I've got an even number there, so I need a plus or minus, because the negative 2 would cancel out to be positive also. All right, one more of these. So again, I try, I have to get rid of the 3, so I'm going to take the cubed root of both sides. So the cubes cancel, and I get y minus 1 equals the cubed root of 32. And now I add 1 to both sides, and so y equals 1 plus the cubed root of 32. Okay. Now, I can't leave it like that. The cubed root of 32 can be simplified. 32 is 2 times 2 times 2 times 2 times 2, so 5 of those. Now if I'm trying to find the cubed root of that, there are 3 2's in there that I could take the cubed root. So if you remember, if we back up a little bit, if I was trying to find the square root of 18, I would say, well, that is the square root of 9 times 2. And the square root of 9 is 3, so I get 3 square roots of 2. Well, I can do the same thing with other roots. This is a cubed root of something that I have 3 of. I have 3 2's. So I take those out, I get 2 times the cubed root of, I only have 2 left, so I'll have to leave those in there. So this is really 1 plus 2 cubed roots of 4. Now I believe we'll be working with this a little bit more in the chapter, so if that didn't make sense, go ahead and write this down. But if you can, you should simplify it. Alright, another thing that comes up when we're working with exponents and equations is this formula, or other formulas like it. And there's all kinds of versions of this. It all just depends on what you're trying to do. But here we have a formula, and it says the rate R at which an initial deposit P will grow to a balance A in T years with interest compounded N times a year is given by this formula. So basically it takes a different formula we've seen before and it just kind of rearranged things. And so now we're supposed to solve for R if we know all of this stuff. So basically I'm going to take these things, I'm going to plug them in for where I know they go, and then I'm going to see what I can do with that. So we have R equals N is 12, A is 2,000, P is 1,000, to the 1 over, N is 12, and T is 11, minus 1. So then it's just a matter of finishing the math here. 12 times 2,000 divided by 1,000 is 2. To the 1 over, that would be 131, I believe. No, 132. Minus 1. And then it's a matter of doing this on a calculator. So you're going to take 2 to this. Remember, you want to take 2 exponent and then use parentheses for 1 divided by 32. 132, sorry. Okay, and then you're going to take that minus 1, and then take that times 12. So I'm not sure what this is going to be. I want you guys to actually figure this out and put it in your notes so that when I check your notes I can see what this is as a decimal. And remind me also to talk about this in class tomorrow. So another place that we can use this would be here we have a basketball has a volume of 455.6 cubic inches. The formula for the volume of a basketball is V equals 4.18879 R cubed. Find the radius of the ball. So we need to find the radius of the ball, so we want to figure this out. Now I have two variables here, V and R, and so one of the things you guys need to be comfortable with doing is getting some random formula and being able to work with it. Now above here it said that the volume of it is 455.6. That means I'm going to take that, I'm going to plug it in for V. So we have 455.6 equals 4.1879 R cubed. And so just like before, I want to get the R cubed by itself, so I can cube root it. 4.18879. So I need to figure out what this is, and it will be equal to R cubed. And so once I figure out what that is, so it'll be 100 and something. Once I figure out what that is, I can take the cube root of both sides, and that will be the radius of the ball. Once again, I'd like to know what this is tomorrow.